What would you do with a brain if you had one?
Do? Why, if I had a brain,
I could while away the hours, conferring with the flowers, consulting with the rain. And my head I'd be scratching
Sully,
while my
what
thoughts
you
were busy
doing?
hatching if I only
Why are
had
you
a
all
brain.
dressing up like a witch?
I'd unravel
Unit 5,
every
Section 3,
riddle,
proving
or end
parallelograms
me in the
congruent.
middle, in trouble
Remember
for a
Parallelogram? He's from the last lesson. Yeah, sorry about that. He taught us all about parallelograms. But how do we know if we have a quadrilateral, whether it's a parallelogram? I mean, last section, basically they said, here's a parallelogram. Here's all the cool stuff about it. Opposite sides congruent. Opposite angles congruent. What do we got? Diagonals bisect each other. All that stuff is true if you have a parallelogram. Well, today what we're going to look at is how do you know when you have a parallelogram? Okay, how do you prove that a quadrilateral is a parallelogram? We're going to use the same theorems that we had before, but we're going to look at their converse, because remember, converse works backwards. Remember back from Unit 2? I know you guys love that unit. All right, so our first theorem, if a quadrilateral is a parallelogram, then its opposite sides are congruent. All right, so remember what that looks like here? We go mark those two, mark these two. Okay, opposite sides are congruent. Does it matter which opposite sides? No, it doesn't. Okay, because all of them are, or both of them are. You only have two pairs here. You have the, north, south, east, west, basically is the way I'm looking at this. So the converse would be you not only have to prove that one set of opposite sides are congruent, you have to prove both, because for a parallelogram, they both are. So that's what the converse of the first theorem is going to be. If a quadrilateral has two pairs of opposite sides congruent, then the quadrilateral is a parallelogram. You have to have both sides congruent, both pairs. Not to each other. They don't all have to be the same, but the opposite sides have to be congruent to each other. All right, so that is the first. You might have to pause it to write these down, because I know that these are blank for you. Next theorem, if a quadrilateral is a parallelogram, then the diagonals bisect each other. Well, the converse of that, if a quadrilateral's diagonals bisect each other, then it's a parallelogram. That's easy enough. I think I have a typo on this one. If a quadrilateral is a parallelogram, then its opposite angles are congruent. All right, if a quadrilateral has two pairs of opposite angles, there's my forgetfulness. We'll put congruent in there. Okay, make sure you write congruent. Then the quadrilateral is a parallelogram. All right, so you need both pairs of opposite angles congruent for the quadrilateral to be a parallelogram. Lastly, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. All right, remember, this is kind of like the first example I showed you. Let's pretend like this is 60 and we got 120 up here. Is that a parallelogram? Well, it could be if this is 120 here. But look, you have to prove that both consecutive angles are supplementary to this angle here. Otherwise, you could get some weird quadrilateral that looks like this. All right, what do we got? 120, 60, maybe like 110. All right, then that's not a parallelogram anymore. That would be bad. So you have to do both pairs. What's it say here? The converse. If an angle of a quadrilateral is supplementary to both of its consecutive angles. So you just got to find an angle, and then the two consecutive angles there, it has to be supplementary to. Then the quadrilateral is a parallelogram. All right, are there any other theorems that we can use or prove now that we know that? Yes, there is, and I'm going to show you a cool one here, and we're going to prove it. This is actually why we do proofs. We've given you a whole bunch of proofs here. We're going to actually prove that if you have the opposite, you pick one opposite side here, one pair of opposite sides. What if they are parallel and congruent? Because right now the only thing we have is two pair congruent, two pair parallel. Okay, what about one pair that's parallel and congruent? All right, is that enough to say that it would be a parallelogram? So we're actually going to do a proof. So here's what our proof is. We have a quadrilateral, and we have a diagonal down there. You'll see why we need that. BC is parallel to DA. Okay, so I've marked those with the little arrows. And BC is congruent to DA. That's what those marks there are. All right, so let's prove that ABCD is a parallelogram. So the statements. First statement's always the easiest. Just write the given down, and your reason is given. Ta-da! Second statement. All right. Angle CBD is congruent to angle ADB. So CBD BD. All right, let's mark that in green. That's this angle right here. Ta-da! Is congruent to ADB. Okay, trace it with your pencil if you have to. Find out which angle we're talking about. So we're talking about that angle and this angle. Hey, wait a second. This looks like parallel line, transversal. What are those angles called there? Do you remember? Those are called, oh, I gotta get my writing utensil back here. Ta-da! I don't know what I'm doing. All right, here we go. Those angles are called what? They alternate and they're on the inside of the parallel lines. Those are alternate interior angles. Okay, so remember the little Z they form? So, like, how do we know they're congruent? Well, you need, if two parallel lines are cut by transversal, then the alternate interior angles, I'm going to abbreviate here because I'm trying to write here on the computer, but you can write it out. The alternate interior angles are congruent. All right, so there's my shorthand. Just barely fits on the screen. How about this one? BD is congruent to BD. BD is congruent to BD. Well, that's this one right here. That's the easiest one. Don't ever get that one wrong. That's the reflexive property. Reflexive property of congruence, technically. All right, because we're proving congruence here. For BCD. All right, let's try a different color. BCD. We're looking at the whole triangle. We're saying the triangles are congruent now. What do we have here? We have side congruent to side. Okay, they gave us that. Ta-da! Side. We have angle. We just proved the angle right there. It's congruent to angle. And then another side is congruent to side. So we have side, angle, side. So these triangles are congruent because side, angle, side is congruent to side, angle, side. Beautiful. That's why our triangles are congruent. So that's why we needed the diagonal. Remember I told you that you'd see why later. Well, now you know why, because we have these triangles are congruent. I'm going to erase a lot of this stuff here. Let's get rid of some of this so we can clean it up a little bit. But we have these two triangles are congruent to each other. All right, so now what's the next statement? BDC is congruent to DBA. Angle BDC. So that's this angle here is congruent to BDC, DBA. DBA. Okay, that's right here. They're congruent to each other. How do we know that? Remember, these two triangles are congruent. We just proved that. So, remember this? CPCTC? Sounds like a rap. There's a challenge out there. Why don't some of you guys make a rap? Put it on YouTube. Give us a link. We'll put it in our video. CPCTC. Corresponding parts of congruent triangles are congruent. That's why these angles are congruent to each other. So, wait a second. Check this out. If you look here and here, we have these two lines. Now, they didn't say they were parallel. But what's this? Aha, transversal. And you have alternate interior angles here, right? Tilt your head to the left so you can see it. Little Z going on there. Alternate interior angles. If you have two parallel lines cut by transversal, the alternate interior angles are congruent. Well, here the angles are congruent, so you want to say that the lines are parallel. So what is that? That is the converse of the alternate interior angles. Remember, that's kind of working backwards. Interior angles theorem. All right, so what does that mean? That the lines are parallel to each other. Well, what did we just prove? They gave us that these are parallel. Remember, I erased those. And now they just told us these are parallel. Well, the opposite sides are parallel. Guess what that is? That's parallelogram. Yay! That's number 7. So ABCD is a parallelogram because that's the definition of a parallelogram. Or you could say, this will work either way, two pairs of opposite sides, put another P there, parallel. Okay? But you can just leave it with definition of parallelogram. And look, we have a new theorem now. If one pair of opposite sides, because look, we just proved this. We had one pair that was both parallel and congruent. And that's all we knew. And guess what? We just proved it's a parallelogram, and that's true every single time. That's why we do these proofs. Ah! Don't be afraid. Cowardly lion. Sully! Why are you acting like that? You're so silly, Sully. All right, so here, the summary. Proving quadrilaterals are parallelograms. This is basically every way that you could do it. If you show that the opposite sides are parallel, or that's the definition of parallelogram. If you show that both pairs of opposite sides are congruent, that's another way to do it. What if the opposite angles are congruent? That's another way to do it. What if you show one angle is supplementary to both consecutive angles? That's another way to do it. What if you show the diagonals bisect each other? That's a way to do it. And lastly, we just proved this, show that one pair of opposite sides are both congruent and parallel. It has to be the same. You can't have it like this. Real quick. You can't have parallel on this side and then congruent on that side. That doesn't work. We don't have a theorem that says that works, and it doesn't work all the time. Sometimes it does, but it doesn't all the time. Okay, you have to have the same two sides that are both congruent and parallel. Wow, so let's look at these and see if we can figure it out. Logical reasoning. Are you given enough information to determine whether the quadrilateral is a parallelogram? All right, what do we have here? Oh, and we have to do that explain. Everybody loves to explain. What do we have here? So we got congruent, congruent. Is that a parallelogram? Enough? Yes, I'm going to put big Y in it. And what's the reason? Two pairs of congruent sides. That works. All right, what about the second one here? What do we have? Diagonals? They bisect each other? Yes. Diagonals bisect. All right. That's easy enough. How about this one here? Diagonals form vertical angles. Don't really know what that's about. Didn't really talk about that. Let's put a frowny face on that one because it's fun to draw frowny faces. How about this one? We have an angle here. Oh, I think I use this example. Why did I use those numbers? You have both consecutive angles are supplementary. Yep. Okay. What do we have to say? Both consecutive angles are supplementary. I'm the worst person to abbreviate. I just put like one letter and then a dot. How about this one here? Congruent, congruent. The opposite, that's not opposite these. I really don't know what's up with that. No, that's not enough information. How about this one? Those little arrows mean parallel and the 6 and the 6. Hey, that means equal measure. That's congruent. Yes. Okay. So we have one pair parallel and congruent. Hey, check that out. I'm about the laziest teacher. You can learn how to abbreviate anything from Mr. Kelly. How about the next one? For what values of x and y is flip a parallelogram? All right, this is just a tricky way to get you to do some algebra. They're going to say, all right, what values do x and y have to be if this is going to be a parallelogram? In other words, what values are going to make these equal, because that's what a parallelogram is, and what values are going to make these equal? Well, we could do 3x. Here's one equation, 3x plus 6. When will that equal y plus 4? All right, you have an x and a y. Let's pause the video. No, don't pause the video. Keep listening. How about these two? 2y plus 2. When will that equal 3y minus 9? Well, look, the first equation you have x's and y's. You can't solve that without some help. The second equation, you only have y's. Let's try some stuff. By stuff, I mean algebra. Okay, subtract 2y. They cancel. You get 2 equals y minus 9. You can add 9 to both sides. And what do we get? 11 equals y. Beautiful. If 11 equals, wait a second, y equals 11. So we're going to plug 11 in here. What's 11 plus 4? 11 plus 4 is 15. Now we can set this up. You can also just plug it right in there in that equation. But we get 3x plus 6 is equal to 15. This is easy to solve. Subtract 6 from each side. You get 3x equals 9 or x equals 3. See how that works? So we just solved x equals 3, y equals 11. Make sure you box both of your answers so we can find it. Wow. Tin Man helping us out with that one. Hey, how about the next one? For what values of x and y are the following parallelograms? All right, here's a little hint. Substitution time. Let's do the first example together. All right, diagonals here bisect each other. This will be a parallelogram if the diagonals bisect each other. And they will only bisect each other if x equals the other side, y plus 2, and at the same time, y plus 10 equals 2x minus 8. Well, if you notice, like both of these equations have x's and y's, you're going to have to do some substitution, which is review. But if you're kind of cloudy on that, you can go back at section 8.2 in algebra. You can go back and watch. Which one was that? I think that was like peanut butter jelly time. What is that? The little banana. All right. But we have to do substitution. Basically, substitution works like this. You have to solve one of the equations for one of the variables. So in this case, we're solving. It's already done for us. Like the first equation is solved for x. It's all by itself. Okay, and x equals y plus 2. That means in the other equation, okay, it's a substitute. It's just like getting taken out of the basketball game. You're gone. Okay, you're going to take this x here, and you're not going to put in x. You're going to put in y plus 2. Let me rewrite the whole equation. Y plus 10 equals 2 times. You don't put x. You put what it's equal to. It's equal to y plus 2. And that's just the x part, and we still have our minus 8. Okay, now, why do we do that? We do that because there's no more x's. And this is just a regular multi-step equation here. You can distribute 2y plus 4 minus 8. All right, now what? Y plus 10. Let's combine some like terms. Y plus 10 equals 2y minus 4. Now what? Let's subtract y from each side. Draw a line. They cancel. 10 equals y. 2y minus 1y is 1y. We have minus 4. You add 4 to both sides, and y is 14. Ta-da! Remember that stuff? How do you find x? Go back to the first equation. We have x equals y plus 2. We just found that y is 14, so x equals 14 plus 2, which is 16. That is how you do a substitution problem. Remember, you can write your answer as a coordinate point, but in this example, we can just leave it. X equals 16, y equals 14. All right, here's one for you to try. Pause the video and do the second example under number 3. Ready? Go!
I would dance and be merry. Life would be a ding-a-dairy if I only had a brain.
Hey, welcome back. I'm going to show you 2 ways to do this problem. 2 ways to do it. Both of them equally sound. One way is better, though, only because it's easier. Here we go. Opposite angles are congruent, so you can set their measures equal to each other. You have x equals 2y. There's our first equation. 4y equals 5x minus 180. There's our second equation. Remember, substitution, you solve one of the equations for a variable. So the first one's already solved for x. In the other equation right here, you take the x out and you put in a 2y. And then it's just off to the races. You do a little solvey-solvey. Get down y equals 30. And then you can plug that in. If y equals 30, then 2 times 30 is 60. That's what x is. The easier way to do it, remember that consecutive angles must be supplementary. So if you look, 2y plus 4y has to equal 180. So then 2y plus 4y is 6y. You get y equals 30, x equals 60. A completely different solution to the same exact problem. You get the same answers either way. So that is it. You have some distance and slope review to do in your application problems. But remember, you got to practice. Get it right. This is Mr. Kelly and Baumholder. Remember, it's nice to be important. It's more
But
important
I'd
to be
face
nice.
a whole box full of them for the chance of getting some brains. Look, I won't be any trouble because I don't need a thing. And I won't try to manage things because I can't think.